Have you ever looked up at the moon and wondered if we could reach out and touch it? What if I told you that, in a way, we can? Imagine billions of laser pointers all aimed at the moon. Would we see a difference? Would our celestial neighbor change color? The answer, as with most things in astronomy, is a bit more complicated than you might think. To understand why, we need to understand how lasers work. Lasers are fascinating devices that have a wide range of applications, from simple pointers to complex medical instruments. They are used in various fields such as communication, entertainment, and even in scientific research. A laser is simply a concentrated beam of light. Unlike ordinary light, which scatters in all directions, a laser beam is highly focused and travels in a straight line. This is what makes lasers so powerful and precise. When you shine a laser pointer, you're sending out a stream of photons, tiny particles of light in a very specific direction. These photons are all moving in unison, which is why the beam appears so sharp and clear. These photons travel through space until they hit something. The distance they can travel depends on the power of the laser and the medium they are traveling through. In a vacuum, they can travel vast distances without losing much energy. When the light hits an object, it can be absorbed, reflected, or scattered. The material properties of the object determine how the light interacts with it. For instance, a mirror will reflect most of the light, while a black surface will absorb it. The way the light interacts with the object determines what we see. This interaction can create beautiful patterns and effects, especially when the light is scattered in different directions. For example, a red apple appears red because it absorbs all colors of light except red, which is reflected back to our eyes. This principle is the same for all objects and colors we see around us. The specific wavelengths of light that are reflected or absorbed give objects their unique colors. Now imagine billions of people pointing lasers at the moon, each person from different corners of the world aiming their tiny beams of light toward that distant celestial body. That's a lot of photons. Each laser pointer emits a stream of photons, tiny particles of light, traveling through the vast expanse of space. However, even with billions of laser pointers, the light would be spread out over the vast surface of the moon. The moon's surface is not only vast, but also uneven, with craters and mountains. The moon is about 240,000 miles away, and its surface area is enormous. To put it in perspective, the moon's surface area is about 14.6 million square miles, roughly the size of Africa. By the time the laser light reaches the moon, it would be so spread out that we wouldn't notice any visible change. The light would disperse, losing its intensity and focus. It would be like shining a flashlight at a giant wall from miles away. You might see a faint glow, but you wouldn't be able to change its color. The sheer distance and the vastness of the surface would dilute the light, making it almost imperceptible. This thought experiment highlights the incredible scale of space and the challenges of making a noticeable impact on celestial bodies. Even with the combined effort of billions, the vastness of the universe remains a formidable barrier. Section 4. Painting the moon? Not so fast. To truly change the color of the moon, we would need an astronomical amount of energy. Remember those photons we talked about? They carry energy. The more photons you have, the more energy you have. To make a noticeable difference in the moon's color, we would need more energy than all the power plants on Earth could generate. It's simply not feasible with our current technology. Section 5. A universe of possibilities. While we may not be able to paint the moon with lasers, the idea itself sparks our imagination. This thought experiment highlights the immense scale of the universe and the limitations of our current technology. The vastness of space is both humbling and inspiring, reminding us of how much there is yet to discover. It also reminds us of the incredible power of light. Light, in its many forms, has the ability to reveal, to guide, and to transform. From the gentle glow of a candle to the intense beam of a laser, light shapes our perception of the world. The fascinating ways light interacts with the world around us are endless. It reflects, refracts, and bends, creating beautiful patterns and phenomena that captivate our senses. The dance of sunlight through the leaves, the shimmer of light on water, all these moments are a testament to light's magic. Even though we can't create a lunar light show, we can still marvel at the moon's beauty. The moon, with its serene glow, has been a source of inspiration for poets, artists, and dreamers throughout history. We can gaze at its craters and imagine the stories they tell. Each phase of the moon brings a new perspective, a new wonder to behold. And as we continue to explore the universe with curiosity and wonder, we are reminded that the possibilities are truly endless. From the smallest particle to the largest galaxy, the universe is a vast playground for our imagination and our quest for knowledge.